Good morning. This is David It's February 4, 2022. I am now here in Los Angeles, California. Okay, guys, I've got a new topic for this afternoon. My topic for this afternoon is integrals leading to logarithms. Okay. Yesterday, I gave you the formulas on how to take the integral of functions leading to logarithms, okay? I will repeat the three given equations or the three equations I've given you yesterday. First one is the integral of db over the square root of b squared plus or minus e squared equal to the natural logarithm of b plus the square root of b squared plus or minus e squared plus c. That's number one. Number two, the integral of db over b squared minus e squared 1 over 2a natural logarithm of b minus a, b plus a plus c. Number three, the integral of db over a squared. A is ahead, minus b squared equal to 1 over 2a natural logarithm of a plus b, a minus b plus c. Okay, so you see the variations under the natural logarithms. It's different for equation number 1 and equation number 2. First one is b minus a over b plus a. Second one, it is a plus b over a minus b. Okay, I will give you example problems on how to use these equations. So you know the variation on how we attack the solution. Example number 1. The integral of dx over 16x squared plus 25. If we try to observe the given equation, from the three integration formulas, it seems it's similar to number 1, right? So actually the given problem is similar to the integral of dv over the square root of b squared plus a squared. And the solution for that one, we will follow this, right? Natural logarithm of b plus the square root of b squared plus a squared plus c. But we must have to identify the value of b in a. Okay? If we try to observe it, b squared is 16x squared. It is this. The one with the variable thing inside the radical. That's the value of b. B squared is 16x squared. Taking the square root of both sides, they are both perfect squares, so b will be 4x. Let's compute for the value of db. db is equal to 4dx. Constant in the function, it should be that constant times its differential. So db is just 4dx. It is not exact. We don't have any 4 on the numerator, right? Again, if you observe the value inside the radical, a squared refers to 25. Okay? Take the square root of both sides. They are both perfect squares, so a will be 5. So we now know the value of b in a, including the value of db. Right? Therefore, the integral of dx over the square root of 16x squared plus 25 equal to the natural logarithm of, okay, we are following this. What is b? b is 4x plus the square root of 16x squared plus 25 plus c. Final answer. As simple as that one. So solution number 1, it's just a matter of comparing it to the formulas, okay, then try to bring out the value of b in a, including db, and try to verify if the value of db is exact or not. Okay? Oh, I think we are missing something over here. The value of db is 4dx, right? So it's not exact. So actually, sorry for this one. There should be 1/4 before it. 1/4. Okay? So the final answer, sorry for that one, this is not exact. It should be 1/4. Why 1/4? We introduce the reciprocal of 4 outside. Okay? After introducing 1/4 outside, it's now perfect to be under formula number 1. And formula number 1 is a natural logarithm of 4x plus the square root of 4x squared plus 25 plus c. There should be 1/4 as a coefficient of the final answer. Sorry for that one. Okay? Because dv is for dx. We didn't have 4 here. So actually, if we will write this one, this should be 1/4 the integral of 4 dx over the square root of 16x squared plus 25. It should be something like that. There should be 4 there, so we introduce 1/4 outside. And if we introduce 4 there, it falls under formula number 1. Natural logarithm of b plus the square root, then this plus c. So it's my mistake. I missed the 1/4. So the final answer should be 1/4 natural logarithm of 4x plus the square root of 16 squared plus 25 plus c. Okay? We make mistakes, but at least we correct it ASAP. Right? Okay, let's proceed with example number 2. Example number 2, the integral of dy over the square root of 2y plus y squared. Okay? If we try to notice it, the value of the terms inside the radical sign, it got all the y functions, so there was no pure constant for the meantime. Right? So for it to fall under formula number 1, okay, because there is a radical sign, obviously it does not fall under formula number 2 or number 3. It should fall under formula number 1. But we are missing some constant term inside, so let's try to find out what will be that missing constant. Actually, the solution is by completing squares. Okay? We will write the term inside, okay? Y squared plus 2y plus c. This c here refers to the missing constant we are looking for, right? And under the quadratic formula, ex squared plus bx plus c, if this is to be factorable to a perfect square term, okay, we should compute for the value of c. And here the value of a is 1, the value of b is 2, and we are computing for the value of c. And the formula for taking the value of c is actually 1/2 of b over a, open bracket, close bracket, quantity square. Okay, so this should be 1/2, 2 over 1, b is 2, a is 1, close bracket, quantity square. Luckily, 2 and 2 cancels. 1 times 1 is 1, over 1 times 1, 1 over 1 is 1, so c is the value of the unknown value of c is 1. So actually, we could rewrite the given problem as this. Okay? It should be y squared plus 2y. The missing constant for it to be a perfect trinomial square is actually plus 1. Okay? So we don't change the problem, we subtract again minus 1. So because 1 minus 1 will be 0, what remains is y squared plus 2y. But we could write it as simply y squared plus 2y plus 1. We group this as one term, and this one here as one term. And this is now factorable to a y plus 1 quantity square minus 1 quantity square. This was the original problem. So this is now similar to the form b squared minus e squared, right? Therefore, the given problem, the integral of dy over 2y plus y squared equal to the integral of dy, okay? After completing the squares, the term inside can be written as y plus 1 quantity square minus 1, okay? Sorry for this one. This minus should be outside. Minus open quantity 1 quantity square. This is similar to the form the integral of db over b square minus a square, where the value of b is y plus 1, db will be equal to dy plus 0, or db is just dy. And a square is actually 1, so a should be 1. Okay, we now identify the value of b, the value of db, the value of a. So we will just follow equation number 1. So the final answer, the integral of dy over 2y plus y square equal to the natural logarithm of b. But what is b? Y plus 1. Sorry for this one, there should be an open quantity here, closed quantity. Okay? Natural logarithm of y plus 1 is b, plus the given square root, y square plus 2y, closed quantity plus c. That's the final answer. It's easy, guys, right? So the main solution for problems relating to logarithms is on how to make the given square functions to be a perfect trinomial square. So just recall your knowledge of algebra. That is ax squared plus bx plus c. We are solving for the value of c because for the meantime we are not given the value of c, but we could compute it by recalling our knowledge of algebra. Okay, last example for this afternoon. The integral of dx over 3x squared plus 4x minus 7. There's no radical sign. So, okay, so it does not fall under formula number 1. So it could either fall under formula number 2 or number 3. There's no radical sign. Okay, let's try to compute for the value of the unknown constant. Okay, we will rewrite the given denominator as 3x squared plus 4x plus c minus 7. This c here is the one we are looking for, okay? So I put that one for the meantime as simply c. Okay? Let's divide all the terms by 3. 3x squared divided by 3 will be x squared. 4x divided by 3 will be 4/3 x. Plus c, the unknown we are looking for, minus 7 over 3. Okay? And if we try to follow this formula here, this one, that the value of c is actually 1/2 of b over a quantity square. Okay? Actually, we can now compute for c. c will be equal to 1/2. b over a is 4/3 quantity square. Okay? 4 and 2 cancels, so this should be 2/3 quantity square. So the unknown value of c is 4/9. So the given problem can be written as x squared plus 4/3 x. The unknown value of c which we are looking for is 4/9. I place it here. For us not to change the problem, we again subtract minus 4/9 because 4/9 minus 4/9 is 0. Okay, minus 7/3. Then we will combine these first 3 terms here. It's now a perfect square. It is factorable to x plus 2/3 quantity square because if we try to square this one, sorry for this one, the square of this one will be x squared. 2/3 times 2/3, 2/3 times 2 is 4/3 x. The pure constant term is the square of 2/3, is 4/9. So this term here is factorable to x plus 2/3 quantity square. And if we try to compute for the simplification of minus 4/9 minus 7/3, it will come out as 5/3 quantity square. Okay? So the given problem can be written as dx over 3x squared plus 4x minus 7 equal to the integral of dx. Okay? The equivalent of this is actually x plus 2/3 quantity square minus 5/3 quantity square. And this is similar to the form the integral of db over b square minus a square. And what is that? It is under formula number 1. Number 2. It is this. Right? It falls under formula number 2. It falls under the integral of dv over b squared minus a squared. And in here, sorry for this one. B squared is equal to x plus 2/3 quantity square, right? Take the square root of both sides. B will be equal to x plus 2/3. 2/3. So dB will be equal to dx plus 0. Or dB is just dx. And a square equal to 5/3 square. Take the square root of both sides. A will be equal to 5/3. So we now identify the value of B, the value of dB, and the value of A. So to bring out the final answer, just follow formula number 2. That will be equal to 1/2 times A, which is 5/3. The natural logarithm of B, which is x plus 2/3, minus A minus 5/3, all over B, x plus 2/3, plus A, that is plus 5/3. Actually, you can now call that one as your final answer, or to simplify it, okay, 2 times 5 is 10, but 3 is underneath, so it will go up, so it will be, the final answer will be 3/10, the natural logarithm of x minus 1 over x plus 7/3. 2/3 minus 5/3 is minus 3/3. Minus 3/3 is minus 1, so that's minus 1, okay? 2/3 plus 5/3 is 7/3. So the bottom portion will be x plus 7/3. Close bracket plus c. That's the final answer. Final answer is 3/10 natural logarithm of x minus 1 or over x plus 7/3 close bracket plus c. It's easy, right? So the key to the solution is on how to take the value of c for the given terms to be a perfect trinomial square. It's always like that under natural logarithms. If you don't know how to compute for the value of c, you're gone. Why for the value of c? For the first term, for it to be a perfect trinomial square. Okay? Right? Okay, we got 3 examples for this afternoon, ladies and gentlemen. So tomorrow, I will give you some more complicated examples on how to integrate problems leading to logarithms. It is under natural logarithm. Okay, guys. We are running smooth. Okay. We are almost to the finish line of the integration. So the next topics will be maybe the applications of integrals and how to compute volume for irregular curves, areas maybe under a parabola or under a hyperbola, something like that. So actually, we are finishing the integration formulas. So when we go to the application, we don't have any problem. So I am familiarizing you guys for the integration gradually. Okay, we are now on the topic leading to logarithms. So maybe the next time around, it could be a topic on hyperbolic integration. Okay, tomorrow or the next topic will be more complicated examples under integrals leading to logarithms. Okay, good afternoon, Los Angeles.